Okay, yeah, so the materials for this talk and Joe's talk as well are up at this link, so hopefully you managed to download it. Apologies for cutting your tea break short, but I hope, yeah, I think you have enough time to get some food. We have quite a bit of material, so that's why I wanted to start early. Yeah, so this is what I'll be talking about today. And maybe before I do that, I just wanted to find out, just about your background, like how many of you use R? Yeah, sure. Okay, almost all of you, right? Okay, and any who use Python? Okay, but the Python ones also use R, right? Okay, so this tutorial will only be in R. How about experience with using ChatGPT or things like that? I guess almost all of you have used it. Okay. Do you use ChatGPT or do you use like the GPT API?
Both.
Both. Okay, so who has experience using the APIs? Okay, not too many. That's perfect. Okay. Because today we'll be learning how to use them. And maybe for those who use it, what do you use it for, or what do you hope to use it for? Just shout out answers. Processing information.
Trying to check how correct like the machine learning labels could be compared to the labels coded by the human beings.
So data labeling kind of annotation.
Yeah.
Okay. Other use cases?
Build chatbots. Build
Chatbots.
Yeah.
Okay. Okay. Yeah. So these are very advanced applications. Any others, like just for homework or things like that? Maybe you don't want to say it in public. That's fine. Okay. Okay. So yeah. So that's great. What we're going to learn today is basically how to use LLMs to annotate data. Okay, so kind of similar to, I guess, what I hope some of you are hoping to use it for. Okay, good. So before we start, I guess a few disclaimers. Thanks for the nice introduction, but I guess as you have heard, I'm not a social scientist by training, so I don't actually know too many of the social science theories and all that. Although I do collaborate and work regularly with social scientists. For example, Joe is my boss, so our team has other social scientists. The tutorial will be in R. But again, R is not my main language. I usually use Python, but I think just for accessibility, I tried to do it in R. Okay, so maybe it's not what you're going to see may not be the best way of doing it in R, because this is just my feeble attempt at trying to get it working in R. Okay, and for more complex applications like building chatbots, you probably don't want to do it in R. Okay, you probably want to do it in Python or something else, right? So those are just disclaimers to set the expectations. You're not going to be building a chatbot today, right? But what I hope you can achieve by today is not really to become an expert on using LLMs in R or LLMs in psychology, but instead, like we see here, to carry out basic annotation tasks with LLMs in R. And I also hope to give you a better conceptual understanding of how LLMs work and their capabilities and limitations. Okay, so that beyond this tutorial, when you go out and you try and do other things, you can build upon that foundation, and work with other people and understand. Maybe you have someone who is more experienced using LLMs. You can talk to them better and get them to and collaborate with them better. Okay, so this is the outline. We will jump right into the hands-on sections. So the first four things will be very hands-on, because I think we've had a lot of talks. So we'll jump right into the code. And then after we've seen some examples, I will come back at the end again and have some slides on further applications that I'm not going to teach you how to do. Okay, so we'll do some basic setup, and then I'll show you how to use LLMs, so-called LLM completions. Okay. And then maybe a bit disappointing, but you might be thinking we're going to learn a lot about LLMs. It turns out to use LLMs, you have to spend a lot of time working with strings, right? Strings are text. So section 3 will actually be where we'll be spending a lot of time doing string processing. Okay, so by the end of today, you will be a string theory expert. And then we will walk through a annotation. We'll walk through an example where we use what we have learned in steps 2 and 3 to annotate a very small data set. Okay. And then after that, I'll have a short talk a bit about practical considerations and then show some other examples. Okay, so the setup. So today we are going to use the OpenAI API to access GPT. So you might have accessed, you might have played with ChatGPT. OpenAI is the company that built ChatGPT, and then they also have GPT models that you can access. So maybe we don't have to do these 3 steps now, okay, because for today I have provided an API key in the code that you can just use. Okay, but in the future, if you want to use GPT to annotate the data, you will need to create an account. You will need to put in some money, okay, to fund the account before you can call it. Okay, so just to say upfront that it's not going to be free, but for today I've put in my own money, so you can use it. Okay, I think it should be enough for what we're going to cover today. Okay, but don't go crazy and start annotating your own data sets. If not, your other participants won't be able to use it. Okay. So maybe just to show you what the website looks like when you do go to it. Right, if you click some of the links, so for example, after creating an account, you can go to this API key section. You don't have to do it now. And then when you click create a new secret key, you can create a key test, right? And then it will generate this key which you can copy, right? And then remember to save it somewhere safe, because you're never going to see this again after you close the window, right? So just remember to save it somewhere. If you forget to save it, don't worry, you can just keep creating keys for free. Okay. And then separately from that, you also have to put money in. So if you go to the billing page, which I've linked in the slides, right? If you go to this billing thing, you can use your own credit card or your supervisor's credit card, right? And add some money here, right? And then you should be good to go. Okay, but not to worry, you don't have to do that today. Today the code will have an API key. Okay. In addition to that, we're going to need 2 packages. So hopefully you've already installed them. One is the OpenAI package, which is an R wrapper that I saw online that allows you to access the API. And then the second one is this package called Glue for string processing. Okay, so we'll see what they do later. Okay, so just get these installed. And then finally, these are the scripts and the data set that we will be using. So hopefully you've already downloaded them using the link. Okay, so we will be going back and forth between the slides and the code. So later you'll see that in some of the slides, there will be these things in gray on the top right. Okay, so these are the corresponding sections of the code. Okay, so that on your own time, when you go back, you can go back and forth between them, and you won't be too lost. Okay, so hopefully we're all okay. I think we all have the stuff downloaded, right, and installed. Okay, so we can get right to it. So the first thing we're going to do is use LLM completions. Okay, so from the OpenAI package, there are a bunch of functions, but the only function that we really need to use today is this create completion function. Okay, so if we go to the RStudio, let's see, is this okay for everyone? Do you want it bigger? Slightly bigger. Slightly bigger. Okay. Something like that. Yeah. Okay. Yeah. So this is the start of the. So there are 2 files: OpenAI_glue and then annotate. Okay, so first we'll go through the OpenAI_glue file, and basically it's just little snippets of code to teach you different things. Okay. So at the start, we are going to need these packages, right? So you load them. Hopefully you've already installed them. If not, you can install them here. Okay, and here you can see here, this is the OpenAI key that I provided. It will work for today. After that, I'll take it down. But for today, it should be fine. And so right here, it's the main function that we will be using. It's this create completion function, right? Okay, so don't worry about all these things inside the arguments. If you just run this for now, okay, what you will get. Okay, sorry, I haven't loaded the application. Okay. Right. So hopefully all of you can run this and then right, so run all the lines above it. Okay, and then if you run this response, you run this create completion function, you'll get a response. Okay. And basically what we have asked is, give me a list of past World Cup winners, right? For example. Okay. And we saved the output in this thing called response. Okay, and if you look at response, you see it's got a bunch of stuff inside it. Okay, so here are some things that you might want to extract. The first is you can check your usage. Okay, so we won't really talk about this, but if you call the usage variable within the response object, you can see there are some prompt tokens, completion tokens, total tokens. Okay, we'll come back to that later. But perhaps right now you're probably more interested in the actual text response. Yeah, and so the way to extract it is to go into this thing here, right? And if you call this, response choices text, you start seeing a response like that, which starts to look like an answer to the question, right? Of a list of past World Cup winners. Okay. It doesn't look very nice at the moment. So some things you can do to make it nicer would be to trim the white space. Okay. So white space are things like these new line characters, right? So you can trim that. If you run that, you get an output like that, which looks a bit nicer. Okay. You can also call cat to print the response. Okay. Cat tends to print things nicer than print. Okay. So don't worry about that. We will use all of that again later. Okay, but basically this is the function that allows us to send this prompt to GPT and then get an answer, right? Now you're probably not too satisfied with this answer at the moment because it's kind of a short list, right? You ask for a list of past winners and it only gives you one winner. And the reason for that is because we are using the default parameters. Okay, so if you scroll down to the second one, you'll see that actually we have additional parameters that we can give. Okay, so maybe if I go back to the slides, we're still talking about the create completion function. We have the model, which is the GPT model we want to query. We'll just stick with this for now. We have our prompt. Okay, so the prompt was the input. Okay, so in this case, if we run this prompt, our prompt is give me a list of past World Cup winners, right? Okay, and then you notice that there are these additional parameters here. So there's something called max tokens and there's something called temperature. Okay. So max tokens is kind of like how many words you're allowing the model to take in and produce. And so the reason why the previous output was so short was because the max tokens, I think by default, is probably something like 20 tokens or something. Okay. So what we can do is we can increase the number of tokens. So in the code, if I set it to 200, let's say, right? And I run this code again. And if I run this tab on the response, okay, now you can see the output is a longer list of World Cup winners, right? Because we have allowed it to produce more words as output. Okay, and actually in our prompt, we said, give me a list of past World Cup winners and write a joke about the last one, right? So we gave a list of World Cup winners and then there's this joke here. Right, it's not a very good joke, but it's some attempt at a joke. Okay, so some things you might notice are that the information cutoff is quite far back, right? There was a World Cup in 2022. The winners are not listed here, okay, because I think you might have heard that the knowledge cutoff for GPT is 2021. Okay, so just keep that in mind. Okay, but other than that, it looks like a pretty good response, right? So that's one thing you can do, increase the number of tokens to get a longer response like this. Okay. The other thing you can do is to increase the temperature. So the temperature kind of controls the amount of randomness in the LLM output. Okay, so we set it at 0, it's basically saying like no randomness. Okay, so I think all of you ran this code, right? Did you all get the same joke? right? Okay, you all got the same joke. Okay, so which is kind of I guess it's kind of nice for some purposes. Okay, but sometimes if you want a bit more randomness, you can increase the temperature to something like 0.5 or 1. Okay, and if we run the prompt again, okay, now you get a slightly different response, and the response you get now will probably be different from whatever you're seeing on my screen at the moment. Okay, so by changing the temperature, you can control how random you want the output to be. Okay, so play around with those. For this tutorial, I'm going to set it as 0 so that we all get the same kind of output. Okay. This randomness can go actually all the way up to 2, but you probably don't want to set it so high. So if you set it to 2, you can see that the output starts becoming. Sometimes it may not even succeed in creating an output if you set the temperature too high. Yeah, let's try 1.5. Okay. You see, when I set the temperature higher, I start getting stuff that looks a bit like gibberish, right? It's not even proper English sentences. Okay, so yeah, they switch to Spanish or something halfway and then go back to English. Okay, so
quick question, sorry.
Yes.
So what would be the benefit of setting the temperature higher?
So it's not. I usually don't set it higher. I'm just showing what happens if you do. It increases the amount of randomness, and the model starts throwing in words that are less probable. Yeah.
So are there any instances where researchers might benefit from having a higher randomness versus a lower?
So let's say if you want to average the model's response over the same prompt over a few times, right? If you set it to 0, you're just going to get the same thing back all the time. If you kind of want some kind of distribution, you can set it to non-zero number. Yeah. If you want to gain an insight into the distribution of responses.
Do you have a threshold or like a recommended point?
I would say don't go above 1.
Okay.
Yeah. But even 1 is kind of random. Like some people like 0.7. Yeah, but like for our stuff, we just run it once, so we just set it to 0. Yeah.
I have a question.
Yes.
So for is that attributable then the generation of kind of the same? Does it mean something like the speed is different? If I want to keep
Okay. It's kind of like fixing the seed, but you don't have any control over what the seed is. Yeah. So if you have a random seed, if you change the seed, you get different things. But here you can't actually change the seed. Right? Yeah, you just yeah, if that makes sense.
So it's not actually speed.
It's not the seed, yeah, it's not the seed. Yeah.
I have. So it's just like a black box. So you don't know how to
Yeah, it's a black box. Yeah.
But I think for most studies, so for the reviewers and the editors who want the repeatedness of
They want the repeatedness, right? Yeah. So if you want replicability, then setting the temperature to 0 would be the best, right? Because when I run it here and when you run it, it's going to be the same outputs. Yeah.
Because Professor Rowan asked one question, and I really want to share insights I got from the previous EMLP. So last year, EMLP had a very cool paper utilizing this randomness. How did they do with it? Is that they want to generate some like fake sentences with like grammar errors. So what they did is just increase the randomness and to choose the less probability, like tokens to fix that sentence. So they got a lot of wrong samples, and they can build a very large data set and then train the model to fix grammar errors. That's quite impressive to me.
Yeah. So yeah, if you want nonsensical outputs for whatever reason, for example, ungrammatical sentences, then you can increase the temperature, right? Yeah. So depending on your use case, yeah. Thanks. Okay. So yeah, basically this is the only function that we will need from the OpenAI package, right? And these are the parameters. Right, so what we're going to do, because we're going to use this function a lot, is we're just going to wrap this into another function. We will create a function that does all this for us, right? So if we go back to the code into section 3, right? Basically, we are creating a function. I'm going to call it LLM. You can call it whatever you want, right? Bot or GPT or something, right? And it's going to take in the prompt, okay? And then it will do all these things for us and extract the response. Okay, so we're just going to make it easier so that we don't have to keep typing all of this stuff. Right, so let's run this. Okay, and now we have that function. We can use it, right? So the prompt is the same, it produces the same thing. Or if you type in the console now, for example, LLM, where is Singapore, right? You get a response here. Singapore is located in Southeast Asia, etc. Right. So now you have this function. It's almost like having ChatGPT inside of RStudio, right? Now, if you've used ChatGPT before, you might start trying to interact with it like ChatGPT. So you might try to ask where or when was it founded, right? So if you look at this conversation, this seems like a perfectly normal ChatGPT conversation. You start with where is Singapore, they give you an answer, then you ask when was it founded, right? What do you think is going to be the response to this if I hit enter? Is it going to tell me when Singapore was founded or not? So if you hit enter, it will tell you it doesn't know what you're talking about, right? It doesn't know what the it is. Okay. And the reason is because this isn't exactly ChatGPT. Okay, so if we go back to the slides, what ChatGPT is actually using is something slightly different. So we don't need this part for the tutorial, okay, but I'm just going to talk about this for a short while, just to give you an understanding of the differences between how we're using the LLM and how you might be interacting with it in ChatGPT. Okay. So the first difference is that ChatGPT uses something called a chat completion. Okay. That's just a different function rather than the completion function we have. Okay. And basically a chat completion takes in a list of messages rather than a prompt. Right. So we look at what we were typing so far, right? If we just call LLM on where is Singapore, right? The input for this is just a prompt, right? Where is Singapore? When was it founded? Okay. ChatGPT doesn't take in a prompt. It takes in a list of messages, right? A whole conversation. Okay. So, for example, this conversation on the left, who won the World Series, Los Angeles Dodgers, where was it played? Okay. And it will reply with the correct answer. Basically, this is represented as a list, right? That you can see here on the right. You have the user saying who won the World Series. Okay, you have ChatGPT, which is the assistant replying with this answer. And then if you have a follow-up question, it just gets added on to that same list of conversations, right? Where was it played? Okay. So the first difference between ChatGPT and the way we're using a prompt is that instead of just one string of text, ChatGPT actually takes in a list of messages, right? A conversation. Okay. So you can see here we have a create chat completion function. Okay. Again, we're not going to use it, but just to show you the differences between what we are doing and what ChatGPT might be doing. Okay. Now, if you look at the list of messages, you'll also notice that there's this first message called the system prompt, right? The role is system, and then there's some content. Okay, and this is usually not displayed when you interact with ChatGPT. Okay, so a system prompt is kind of like a way to get ChatGPT to produce different behaviors or to act in slightly different ways. Okay, so if we go back to the code, okay, so the first one was just an example on carrying out the conversation, right? So if you run that, you'll see in this conversation, you ask who won the World Series, Los Angeles Dodgers. If you ask where was it played, you actually get a response that makes sense. Okay, so similarly, if you wrote here, where is Singapore? Okay, right, and then here maybe the response was in Southeast Asia, right? And then now if you wanted to continue conversation, you can ask when was it founded, right? So if you run something like this, okay, you will get some kind of response rather than the LLM saying, I don't know what you're talking about, right, that we saw earlier. Okay. So that is the chat completion. And so I was talking about the system role here, right? So usually the role, you usually tell the chatbot, you're a helpful assistant, right? But you can have fun with the prompt. Okay, you can change the prompt to something like, yeah, you are a helpful assistant who always replies in Singlish. Okay, so if you run that and you ask who won the World Series, and then you get the response, you get something like this attempt at sounding Singlish. Okay, so yeah, right. Hey bro, Los Angeles Dodgers lah, right? Very sure win for them. Yeah, I remember that. Right. So by changing the system prompts, so this is something you don't usually see in the ChatGPT conversation. It happens before the conversation even starts. Right. You're telling the agent how it should behave like. Right. So you can try different things, right? You can say always reply in Chinese, right? Or always reply, saying you're so handsome at the start of every response, right? If you want that, right? You can do that, give it instructions and it will behave in a different way. Okay.
Question.
Yes.
So in section 4 of the code, you mentioned that after you define the role as a user and you've asked a question, you've again mentioned role is the assistant and provided a sample output. Right?
Yes.
Why is that needed? Can it not? Because for the subsequent question, it generated the output.
Okay. So you're asking why I needed to provide the answer here, right? Okay. So this is just kind of like a mock-up of. So what you would do is you would just run something with the first two, and then it gives a response, and then I will copy that response over and put it
It
here.
will not work without the initial, without the initiation.
Okay, I'll get back to this later. Okay, and then we will. Yeah. So I have a slide about exactly this. So we'll talk about that in a bit. Okay. But yeah, good question. So again, this is just to show you differences between let's say ChatGPT and GPT that we're using. By changing the system prompt, you can get different kinds of behaviors, right? So when you change them, they're sometimes called different assistants or different agents. Okay, you might have heard that. It's basically the same model but with a different system prompt. Okay, so you can experiment with them. Okay, but we won't really use that today. Now, one of the reasons why we're not going to talk about chat completions is that actually the completions and chat completions aren't so different. So for example, a chat might look something like that, right? And you have to give this list of messages as input. Okay, but you can always convert them into just a single prompt, right? Like you see on the right, you just write out everything in a single string. You write out user said this, assistant said this, user said this, and then ask it to fill in the blank, right? Assistant says something, right? So you can implement the behavior of chat completions using just ordinary completions. Okay. So you can see that in the code, section 6. If you run that, right? I've written this long prompt here. And then if you look at the response, it's a response that would continue the conversation, right? It's a valid response to that conversation. Okay. But the other way works as well. You can also implement completions using just the chat interface. Okay. And the way to do that would just be to dump everything into the system prompt. Okay, so in section 7, I've created another function that basically calls the chat completion. Okay, and then we put our input here, right? It takes in a list of messages, right? But you can always have a list of messages that only has one thing, right? Which is your instruction to the thing. Right? So in this case, the whole input, rather than a back and forth conversation, is just a system prompt with a single question. I think our prompt was a list of World Cup winners, right? So, but if we run that, oh, okay, yeah, we get, maybe the prompt was about the World Series. But my point is that actually chat completions and completions aren't too different. Okay, so we really only need to care about one of them. Okay, so for the rest of the tutorial, we'll only be working with completions. Okay, which means that our input will always be something like this on the right-hand side. We won't have to worry about handling, a list of messages. We only just need to give in a single prompt with all the information that we want to extract from it. Okay. And so what we'll see is that by crafting different kinds of prompts, we can achieve different tasks. Okay. Now, to go back to your question on why I needed to kind of like fake the response here, right? So again, this is not going to be needed for tutorial, but I thought it would be something interesting to share. So this might be something that which some of you might know, which is that the LLM is actually a stateless machine, right? Stateless just means that it has no memory of past interactions, right? So you can think of it as this black box. Each LLM has a fixed set of training data and a fixed model algorithm going on inside it, right? Those are all fixed, right? Nothing changes. So everything in the box is fixed. And so let's say you're having a conversation with the LLM. You ask, who won the World Series, right? It sees that question, it replies with something, like the Los Angeles Dodgers, right? And so if you want to continue the conversation, maybe the next question would be, you want to ask where was it played, right? For it to successfully continue the conversation, you actually have to take the previous inputs and outputs, insert it into the new input, right? And then add your question, where was it played, right? So you can see these two parts here actually have to be fed back in. And then you add the new line that you want to save, right? So that's what we're trying to mimic just now, right? We pretend that we already had an output previously. We still have to give it the previous output. Okay? And then you can continue the conversation and it will make sense. Okay? If you just ask, where was it played, right? It's not going to know what you're talking about. Okay, so when you use ChatGPT, basically they maintain this illusion of continuity, right? Basically by just, every time you type a new thing, it actually inputs the entire sequence of everything that you and the ChatGPT has said, and then your new input, right? And then feeds that all in and waits for a response. Okay, so it's not magic, it's just a clever bit of engineering, right? To just keep feeding in the past responses. Okay, and in fact, they are stateless next word predictors. Okay, so behind the scenes, what the LLM is actually doing, it's not really generating a full sentence, just like that. Okay, what actually happens, let's say we have a prompt like this, right? You are a helpful assistant, you want to continue the conversation, right? If you feed this into an LLM, it actually just tries to predict what is the next most probable word, right? Just one word at a time. Okay. It tries to predict the next most probable word. There'll be a bunch of words with a bunch of probabilities. Okay. And then to continue the response, it feeds all of this in again and updates the prompt with the new word that it previously generated. Okay. So this is the same prompt with just one more word, right? And then it's fed back in again to the LLM to ask, okay, now that you know this previous word, what's the next word, right? So maybe after the next word would be like the World Series or the 2020 World Series, right? So maybe you have some probability like that. Okay. And then after that, it selects the next word and on it goes. Okay. So you might have heard that LLMs are next word predictors, right? This is what they are, right? Of course, we don't see this because when we call for a response, on the OpenAI side, they'll do all of this, and then only when it's like, a sentence do they give you the response. Okay? But you kind of can get a sense that this is happening if you use ChatGPT, because if you ask it for a response, usually it generates the responses live, right? You can see the words coming out one at a time. Okay, so this is what is happening. Okay. So yeah, just to give you a bit of background on how they work. Okay. So we won't need any of these. Okay. So just to I just thought this would be fun to learn. Okay. So if we go back to the code, right? All we will need really is this function LLM, which we defined above. Yeah, I'm not going to scroll up, but now we have this function, right, that we can call, and then we can now call this function, and this will be the main LLM function that we will be using for the rest of the tutorial. Okay. Any questions on the LLM side of things before we go on to string processing? Okay, hopefully it wasn't too confusing. So the whole point is that we now have this function, LLM, and then insert your text, right? And then that's all we'll be using. Okay. Now let's go on to the next section, which is about string processing. So actually most of this tutorial will be about teaching you how to process strings, right? Strings are these text inputs and outputs, right? And the reason why we need to process strings is because the LLM takes text as input and gives us text as output, right? So in order to make use of the inputs and outputs well, we need to know how to do string processing. Okay, so actually this tutorial is more of a tutorial on string processing than using LLMs, right? Because LLMs are, as we saw, are very easy to use. Okay, so let's do string processing. Okay. So suppose you want to use an LLM to compile a list of ingredients to make different desserts. Okay, let's just imagine, right? Chiffon cake, pineapple tarts, matcha Swiss roll. And now you know how to use LLMs. Maybe your instinct is to go and say, right, LLM, what ingredients do I need to make chiffon cake, right? So now we have the LLM, we can do that. Okay, we can maybe use cat to make the response a bit nicer. Right, it prints out this nice list of ingredients. Okay, so that's great. And then if you want to make pineapple tarts instead, right, what will you do? You could go back and then manually change this, right, to pineapple tarts, right? Okay, and then you get a different list of ingredients. Okay, so that's all fine and good. Okay, but after a while, it might feel a bit repetitive, right? Because basically you're just the prompt is more or less the same. List the ingredients needed to make some dessert, right? And then instead of typing the whole thing again, you hope that there's some quick way to just insert the dessert there. Okay, and then we can iterate through our list of desserts. Okay, so we will see how to do this. Okay, so we will do this using a package called glue. Okay. So we technically don't have to use a package glue. I think R comes with functions like paste or cat that allow you to combine different strings together. So for example, you could say, paste, list the ingredients needed to make, right? And then dessert would be some other variable that is defined, right? And then this will give you the sentence, list the ingredients needed to make chiffon cake, right? Or pineapple tart, so forth. Okay, we can do that. But for today, we're going to use a package called glue, which requires the package to be installed. Okay, and the reason why I like it is for simple cases, we don't really need it. But as we'll see when we get to more complex examples, this will be very, very helpful. Okay. So if we go to the code, here's an example showing the basic usage of glue. Okay, so let's say we define something called dessert, right? So dessert is chiffon cake, right? Now, if you look at this string, it says list of ingredients needed to make, and then we have curly brackets dessert, right? If you just printed that string, it wouldn't have the word chiffon cake in it. It would just say curly bracket dessert. Okay? But if you use the package glue, you use the function glue from the package, and you call this string, Oops. You get this string, list the ingredients needed to make chiffon cake, right? So basically what glue does is it takes variables that you have previously defined and then it just glues them in at the correct place in your string. Okay. So I think you can see why that might be very useful. Okay. Here we didn't need to specify what dessert was because we already defined it in section 8. But if you wanted to, you could use something like that, right? You could write glue, and then here is your string with dessert here, right? And then you say dessert is ice cream. Okay, and then if you run this again, it's going to replace the input with ice cream. Okay, so these are just different ways to use glue. Okay, and the next example here is just showing you how glue might be a bit more practical than using paste. Right, let's say you have a longer query that has many different parts. Right, if you want to know what is the currency, right, of Singapore. Right, so if you run it like that, you get the string. What is the currency of Singapore? But if you want to change it to, let's say, maybe you have a list of different kinds of information, currency, capital, population, and so forth. Right, if you want to iterate through all of them, then by setting this info as a variable, you can just change that variable, right? This. Yeah, and you get a string like, what is the capital of Singapore, right? And then you can change it to, let's say, change the country to Malaysia, right? And you get what is the capital of Malaysia and so forth, right? So this is just an example of how you use a loop. It's not so useful for just a single example because if it's just a single example, I could have just typed it directly in here, right? Why do I need to do this complicated thing? Okay, but it will be very useful when we iterate through a list. Okay, so yeah, so let's go down to section 9. Okay, let's say we have a list of desserts, right? So desserts is a list of chiffon cake, pineapple tart, my Swiss roll. Right, so we just type this once, okay, and then we just iterate through that list of desserts, asking it to print this string, right? Right, so if you run that piece of code, you see you get immediately 3 different strings. Right? Ingredients to make chiffon cake, pineapple tart, Swiss roll. Okay, so this will be very useful for us because, for example, you could have 10,000 Twitter posts, right? And you want to annotate all of them. Okay, what you can do is you can iterate through that whole list of posts. Every time you just keep inserting the new post, right? Rather than having to type it out. You don't want to do that. Yeah. So that will be how we will be using loop. Questions so far? We okay? Okay. Good. Okay, so we'll be using glue, and the input to glue we'll be using these kinds of strings. For example, list the ingredients needed to make curly brackets desserts, right? Or what is the curly bracket info or curly bracket country, right? Or like I said, what are topics mentioned in the following Reddit posts, right? And then you insert the post. Okay. So just to establish some terminology, I will refer to these kinds of things as prompt templates. Right? They're not the prompt itself, they are the template for the prompt. After you insert the variables, then it becomes the prompt. Okay. So a prompt would then be the prompt template along with the variables glued in. Okay. So after gluing in the variables, you get these strings here, right, which are the prompts. Okay. And these prompts will be the final inputs to the LLM. Okay. So we have the prompt templates with placeholders. Fill in those placeholders, you get the prompt, and then that's the input to the LLM. Right, so here we have an example of a prompt template in section 10. List the ingredients needed to make, dessert, right? So this thing that we saw before is a prompt template. Okay. And we can assign this to a variable. Okay. And then when we call glue on that thing, right? Glue is going to look into the prompt template, see that it needs to look for a dessert, and well, we have a dessert variable here, right? So it's going to glue it in and then print it out. Okay, so if we run this piece of code, right, oh, and it calls the LLM as well. Okay, so again, if we step through this line of code, we're going to run through the list of desserts that we defined earlier. For each dessert, glue is going to glue that dessert into the prompt so that we get a new prompt, list the ingredients needed to make chiffon cake, right? And then pineapple tarts and so forth. Okay. Then we are going to feed that prompt into the LLM. Okay, and then we get the response, and then I'm just going to print it. Okay, so you can see here, I have just stepped through the list of my 3 desserts, and I get ingredients for all of them, right? So the first one will be chiffon cake. I don't know if this is correct, but yeah, we just take it as it is. Then we have pineapple tarts, right? And then further down, matcha Swiss roll, right? And then we get a list of things. So this is the template that we're going to use, this pattern, okay, when we annotate our data sets. We're going to have a prompt template. We're going to have a prompt template, right? We're going to iterate through something, maybe our data set or something like that. Okay. When we iterate through, we will glue that thing into the prompt. Then we will call the LLM on that prompt, and then we'll get the output out. Okay. And then basically that's it, right? And we just keep doing that for different things. Okay. Make sense? Are we okay with this? Any questions? Yes.
Yeah, I'm wondering, can we like ask follow-up questions in the ChatGPT through this API?
Yes. So you can ask follow-up questions, but it will take a bit of work. So follow-up question, to ask a follow-up question, you will need to, like I said, you will need to manually feed in the previous thing that you asked, and then your follow-up question. So you can do that, but you need to code the, right? So here's an example, right? In this case, we have an LLM giving us a list of ingredients, right? Let's say the follow-up question from that is, what do you want to ask for the ingredients? What is the, I don't know, what can I ask about this list of ingredients? Roughly how much would it cost, right? Let's say, maybe, so after list of ingredients, I want a rough estimate of how much it would cost. Okay, so we can try to do that. Let me do this on the fly. So a new prompt would be, how much would it cost to buy the ingredients listed below, right? Just for convenience, I'm just going to dump the whole response here. But I don't know if it will work. Okay. Just gonna, okay, let's try this. Let's fingers crossed. Okay, wait, sorry. Let me not print the prompt because it's a bit confusing. Right? Let me just print the final. Oh, sorry, I didn't call the other. Okay, so this is live coding. Let's hope this works. Okay, fine. Okay, but at least you can see how you would ask a follow-up question, right? You have to manually put it in, you have to program that follow-up question in, and then you have to think about what inputs from the previous response you want to put into your follow-up question, and then feed it in, right, to get the response. Right? Does this give you an idea of?
Yeah, it's like
follow-up
I
question?
need to copy like the question that I asked previously in the current in this prompt.
Not so much the question, but the response that was previously given.
Oh, I see.
Yeah, right. Because let's not ask it for cost of ingredients since it doesn't know. But let's what is the 5th ingredient? Let's say. What is the 5th ingredient in the list below? Right. Let's try this. Right, let's say that's your follow-up question. Oh, sorry, I didn't glue it. That's why it's not working. Okay. Yes. Yeah, sorry. Let's do it again. Okay, yes, better. Okay, so this is an example of asking follow-up questions, right? So first you list the ingredients needed to make the dessert, right? That's your first prompt, right? Then it gives you a response, which is a list of ingredients. And then let's say your follow-up question is, what's the fifth ingredient, right? So you write out what is the fifth ingredient, and you need to feed in the previous response that it gave you, right? And then that's your follow-up. And then if you want, you can keep asking follow-up questions. Have a new prompt, feed in the previous response, and then go so on. Okay. Does that make sense?
Yes.
Yeah. Okay. Cool. Okay, so that's for prompt templates. We'll be using that quite a bit. Okay. Now, something else you might want to do is that in a lot of these cases, for example, in an annotation task, right, or in this example, right, you ask for a list of ingredients. It gives you something that looks like a list, but it's not actually a list, right? It's actually just a long string, right? And sometimes it might be useful for you to convert it back into an actual list, right, or a vector. Okay, so for example, here is the kind of desired output I want. Right, this is a string, a single string, and maybe all I want is a list of ingredients like that, right? So this is the same ingredients, but they're now each individual strings and then placed into one big list. Don't know what that was. Oh, okay. Okay, so we will see that how to do that in section 11. Okay. Let's say we have a bunch of ingredients. Okay, maybe this was the output for one of them. Okay, and I'm just going to step you through this code, but don't worry, at the end, I'll provide you a function that does all of that. Okay, so how might we want to do that? We're not going to call the LLM, we're just going to do string processing. So I will first initialize an empty list. Okay, then I will take the ingredients, right, and get a list of lines. Okay, so let's just run them one by one. So I have this string of ingredients, right? Then I start with an empty list. Okay, and then let's split them into lines. Okay, so at this stage, if you call this lines code and look at what it looks like, it's a list of lines, right? So basically, we have split this long string into a list of lines. Okay, so you might be happy with that as a list, but you may not really like it at the moment, right? You notice there's still some that are empty. Okay, and then you may not really want the number in front, right? Or the point from the bullet point in front. Okay. So we are going to go through all of these lines. And first, we are going to remove all these digits from the start of the line. Okay, so don't really have to worry about what it does, but basically it's going to look for all these digits and spaces and dashes, and it's going to replace them, right? So it's going to run through all of them. So all of this two dot butter will just become butter, right? This thing will just become egg yolks, right? And then it's going to trim any white space because we don't really care about spaces in front and behind. And then it's going to check if the length is more than 0. So the reason for that is so that we can avoid these kinds of just empty lines, right? But sometimes GPT will give you empty lines if you don't really want. Okay. And if it's not 0, we add it to our list. Okay. So if I run this, and then I look at the output list, right? We get this, we get this list of ingredients. Okay, so that's nice. That's what. So we have one function now that converts a string to a list, right? Separates it out and it's that. Because we are going to use this quite often, I've created a function for this, right? I just call it string to list. Okay, it takes in a string, okay, and it will output the list. Okay, so This is something that you can just copy and paste and then use it in your code if you want. So if we call string to list on ingredients, right, it just produces this list of ingredients. Okay. Sometimes you want to go the other way. So sometimes if we have now a list of ingredients, okay, if we want to feed this back into the LLM, maybe we want it as a single string. Okay, so this is going the other way, converting this list of ingredients into a string. Okay, and we can do that as well using another function, list to string, which we'll see in the next section. Okay, so here we have our ingredient list. Okay, and then I just define this function. This one is a lot simpler. It seems like R's case allows you to do it quite well. Okay, so you don't need to worry about what the code does, but to read the name of the function, it should be clear what it's doing. Right? List to string, and then if you print it out, you see that if you call it on the ingredient list, what you get back is actually a single string. Okay. So we will use this two functions, right, going back and forth between strings and lists. Why do we need to use them? Because as we saw, let's say, you know, the question about the follow-up question, right? Maybe you, so the LLM tends to, or in many annotation tasks, we will usually ask the LLM to produce a list of points, right? A list of emotions, a list of issues or problems, right? And when you ask an LLM to do that, it gives you this list here. Okay? And if you want to do further analysis on how many times this emotion appears, for example, right, it's often more useful to researchers if we convert it into a list. Right? So that's why we want to convert a string to a list. Okay? But then sometimes if we want to ask follow-up questions on that list, right? If we save the previous string, then that's good. We can use that same string. But sometimes we have some other list of things, right? Maybe now you have a list of maybe you have a fixed set of emotions that you want the LLM to detect in some other post, right? So you have anger, joy, sadness, and so forth, right? You have some fixed list, right? To feed that list of emotions into the prompt, you have to first convert it into just one string, right? So then we will use this function, convert it into a string, insert that into the prompt using the glue, okay, and then ask the LLM to see which of these emotions are present in this post, okay, for example. Okay, so converting strings to lists and lists to string is quite useful when we handle the input and output for the LLM. Okay. Questions about that? Okay, so there are those two functions. We will just basically use those functions. Don't really have to worry about how they work. Okay, lastly, sometimes you want to check the presence of a substring. Okay. So for example, if you ask an LLM, read this person's Twitter post, and to what extent do you think the author would agree with the following statement? I like to party, right? Some personality questionnaire, right? And then the LLM will give you a response like strongly disagree, disagree, agree, and so forth, right? You can just take that output as it is, okay, but usually we want to pass that output into something else, right? For example, strongly disagree is 1, disagree is 2, agree is 3, strongly agree is 4, right? So to convert it to that kind of numerical response, you need to check for the presence of a particular substring in a longer string. Okay? So you can do this with this function grepLogical, okay, which comes in R, okay, but we might want to have some additional functionality. So we're going to create a function that does it for us. Okay, so come back to this slide later, but if we look at section 14 of the code, okay, let's not worry about the code first. Let's just run the function, which we call contains, okay, and then try it on different outputs. Right, so we have this function, okay, and then we have a response. Okay, and so let's say in this line, we want to see if the response contains disagree, right? So we can just run that and then, oops, right? It returns true, right? Because disagree is in the response. Okay. Now, in the next line, the way I've set it up, my function contains doesn't care about the case of the words, right? So you can see here, it checks for the presence of disagree, okay, but actually this string disagree does not appear here, okay, because here is lowercase, right? So so depending on the use case, you may or may not want to care about the capitalization. I think most of the time you don't care about the capitalization, right? Whether disagree is capitalized or not doesn't matter, right? So so actually in the function, I've already made it such that it will automatically convert everything to lowercase. So that's why this returns true, okay, which is the behavior that you expect, right? You can play around with some of the parameters. So if you look at the function, it takes in the pattern, it takes in the string, okay, and then it takes in a start and a stop number, and whether or not to lowercase it. Okay, so if we set the lowercase to false and run it, you see that it returns false. Okay, because if you, without converting everything to lowercase, this string, disagree, actually does not appear in this other string. Okay. And sometimes we want to control the start and the stop point as well. Okay, so this last example here, if we say check only in the first 10 characters of the string whether disagree appears. Okay. And then if you set it at 10, then even though disagree would appear later in the string, because it doesn't appear in the first 10 characters, it is going to return false. Okay. So going back to the slide, so again, oftentimes you want to check whether some string is contained in the response. Okay. And sometimes we only want to limit ourselves to a certain part of the string, okay, usually the front part of the string, okay, because you might ask an LLM to say, just reply with agree or disagree. Okay, most of the time the LLM will just reply agree or disagree, but sometimes it will say agree, and then maybe you'll go on a long spiel and explain why it agrees or disagrees, and maybe in the explanation it mentions the word disagree, right? So so if the response is very long, we may not want to match the later parts of the response. Okay, so that's why we sometimes want to just restrict ourselves to which part of the string we want to match. Okay, and then the second one was that sometimes it might be more convenient to convert everything to, let's say, lowercase, right, before matching. Okay. So that's what the function contains does. And so in the next slide, here's an example of how we might use this function to convert a response into a Likert scale number, right, 1 to 4. Okay. So maybe the LLM responds strongly agree. Through this list, if it contains strongly disagree, we reply 1. Right? If it contains strongly disagree, if it contains disagree, we reply 2. If it contains agree, we reply 3, and then otherwise it returns 4. Right? So this is an example of how we can pass the output. Yeah. Now, can anyone tell me what you think the number will be? Who says 4? Who's 4? 3? 3? Right. So if you run this code, it will actually return 3. And the reason why, as you might have guessed, is because the word agree appears there, right? So if you are not careful about the order in which you check your patterns, you might get slightly misleading responses, right? So if you ran this on a whole data set, you might be realizing that you'll never see number 4 at all. Okay. So the order of the matching does matter. It's just by switching these around, you would end up matching with strongly agree, right? Yeah. Okay. If you put agree, if you put this third line contains agree right at the start, right? You realize that it matches everything, right? So everything is going to give you agree, even if they say disagree. Okay, so so these are just some issues that you have to keep in mind when you do string processing. So again, if we go down to number 15, right? Strongly agree, we run this code, okay, and check the result. It gives me 4. Okay, but if I switch the order of these two things, it will give me 3. Okay. Okay, so that's it for string processing. That was a bit of a dry technical session, but hopefully you see why it's necessary when we are interacting with the inputs and outputs of the LLM. Okay, any questions about those sections? Okay. If not, we will go to the next section, which is a bit more fun, I think. It will be an example of an annotation task. Okay. So let's go to the next script, annotate.r. So here is what we're going to do. I provided you this data set, career advice short. Okay. And basically what this data set has are top level Reddit posts from a career advice forum. Okay. Actually, we collected more, but for today, I think I only showed you 15. Okay, so as not to spend too much of my money. Right. So let's see if I can open it. So if we open the CSV file, you see that this is what it contains. You have post ID, the date it was created, the author, the subreddit. Okay, so these are all from the career advice subreddit. And then you have the post title and the post description. Right, so these are all people asking about different kinds of career advice. Right, where they talk about their problems and so forth. Right, so everyone's just asking about career advice, and you can see some people write a lot, some people write less. Okay, so maybe you're interested in understanding what young people these days are looking for when they seek career advice, right? So one way you could do that would be to take this data set, hire some research assistants, and then get them to annotate it, right? Which might be fine for 15 posts, but if you have 2,000 posts, then that might get a bit time consuming. What we're going to do today is to use the LLM to do the following things. We will first get the LLM to annotate the post, extract any problems or issues. Okay. Then, so for each post, we will get a list of problems or issues. Okay. Then there will be a lot of different problems and issues mentioned. So the next step we want to do is to maybe summarize it to get a final list of maybe 20 main themes, right, that are present there. And then if all you're interested in is that final list of themes, then actually you can stop there. Okay, but sometimes you might be interested in taking that list of themes and then going back to the same set of posts and then re-annotating it based on just those 20 themes. Right? Okay, so this is a workflow that I think most of you might be familiar with, but maybe you have been using humans to do it, right, rather than LLMs. Okay, so we'll step through this and we'll see where our string processing comes in. We'll start to reap the benefits of that. Okay, so first, basically what we're going to do is we are going to iterate through the data set with a prompt that looks like the following. Okay, read the following post, then we put the post. Okay, then we ask, based on this post, respond with a list of problems, issues, or concerns. Right? And if the post doesn't mention any of them, respond with any. Okay, so this is an example of a prompt template. Okay, and then we will be inserting the relevant data into the respective parts of the prompt template. So this is an example of a prompt, but since some of you may not have that much experience in crafting prompts, I thought it would be good to break down what is going on in this prompt template, right? Provide a kind of a structure that prompt templates that you can use for future prompt templates. Okay. So first of all, we see that the first line is actually providing context to the LLM, right? You don't just give it a post and ask it to identify stuff. I mean, you can, but if you think it might be useful to know that this post is actually from a career advice forum, right? Then tell the LLM, right? This is a post from a career advice forum, right? So you provide some context, and then you insert the relevant data. Okay, and we didn't just dump the data in like that. You see in red, we have so-called delimiters, right? That say post and then end of post, right? If you want, you can say start of post, end of post, right? These are delimiters. So why do we do this? So you imagine you without the delimiters, the LLM is probably going to know when the post starts. But then, on Reddit, people can write a lot of stuff, right? It's going to be a very long chunk of text. And then it doesn't know when the post ends. And then it doesn't know when your next set of instructions starts, right? So you just imagine seeing a whole wall of text. As a human, if you read it, you're probably going to ignore whatever's happening below, right? And not actually, follow the instructions here. Okay, so if you have data like a Reddit post or Twitter post, it's often good to have a delimiter specifying, okay, this is the end of the data, right? Then what comes next is your next set of instructions. Okay, so it's good to have delimiters around your data. Okay. After you do that, you can give instructions on the task, right? The LLM doesn't know what you want to do with the post, right? So you can tell it, based on this post, respond with a list of, in this case, problems, issues, or concerns, right? If you're interested in something else, then say that instead, right? What are the emotions, right? Or how old do you think this person is, right? For example. So give the instructions. And then if you actually ran this prompt without the last bit, in the data set that I gave, you'll notice that there are actually some posts that do not mention any problems, right? For example, this post here is just asking a question and they don't write anything in the description. Okay. And if you run this annotation task on that post, you'll find that the LM will still make up some problems. Okay. It tends to try and please you. If you ask for problems, it will give you problems. Okay. So it's often good to include kind of like fallback or additional instructions, like, if the post does not mention any problem, respond with NA, right? Telling it that it's okay to not respond with any list of problems. Okay, so this is an example of a post, a prompt. And what we're going to do is we'll iterate through the data set with this prompt. So if we go over to the annotate.r code, okay, the whole first part is just copying out functions that we saw in the other script. Okay, so I won't go through them, right? This whole section here is just the same functions that we saw earlier, right? List to strings, contains, and so forth. Okay, so we can use all of those functions. So first we will read our data, right? So read it and then replace empty posts with blank. Okay, and so if we look at our data frame, we see we have that same CSV file, right, inside with all the post titles and descriptions. Okay. And then we have our prompt template, which is what we saw in the slides. Okay. And so what we're going to do is we are going to, in section 2 of this code, we're going to step through every row of the data frame. Okay. So so n is the number of rows. Okay, let's ignore the progress bar for now, but n is the number of rows. So we are going to step through each of the rows. Okay, and then for each row, we will extract the post title, okay, and the post description, right? Because that is the data that we need to feed into the prompt. Okay, once we have extracted that, we can glue those into the prompt, right? So we get the prompt. For today, I will save the prompt as well, but you may or may not want to save the actual prompt, but let's just save it so that we can see what the prompt is. Okay, and then we call LLM on that prompt. Okay, and then save the response here. Okay, and so let's run it. And this will take a while. So as you're running it, you can see over here you have this nice progress bar that's updating. Okay, so that's what these functions are for, this progress bar thing and this update progress bar. Okay. And the reason why you want to do that is, so you don't have to do that, but as you can see, it's not instantaneous, right? It takes about 1+ second for each post. And if you have 10,000 posts, if you just run this without a progress bar, you're just going to sit there and wait, right? You're not going to know when it's ending, how close you are to ending. Okay, so for this reason, I find it useful to have a progress bar. Okay. And so if you run it, now you can see that it's complete. And if we take a look at our data frame, we now see we have two new columns. One of it is the prompt and one of it is the annotation. So, so if you want, you can look at the values in the prompt and see that the LLM has correctly inserted the correct data. Okay, but we won't do that. We will focus more on the outputs, which is this thing here. Right, so we see we have this whole list of problems, right, that were listed by the LLM. So that's step one. We get it to annotate. There's no hard and fast rule on what makes a good prompt. So the previous one was just an example, but here's another example, right? You can use the first person voice, right? Based on the following post, I have come up with a following list of problems, right? And then leave it blank and then get the LLM to fill it in. You can be creative in how you craft your prompt. Okay, but you can see that the structure of the prompt, it has the same kind of parts, right? It has the context, the delimiters, the instructions, and the data. Okay, so play around with it until you get something that, until you get a prompt that produces outputs that you want. Now that we have done that, we will group all these lists of points together, okay, and try to extract a list of themes. Okay, so this is what we have done on the left-hand side. For each post, we have a list of points, right? I'm going to consolidate them all into a single list, okay, and then ask it to summarize that list of points. Okay. So we go over to the code. In section 3, we are going to consolidate all the points from our data frame into a single list. So if we run this, basically it's just concatenating our annotations into a final list of all points. Here you see we have used our function string to list, okay, because each annotation is a string, right? So what we're doing is for each annotation, we convert it into a list, and then we just keep adding it onto our big master list of all the points. So this all points thing here will be this giant list of consolidated points in the slides. And what we're going to do is we are going to feed this whole list of points into a prompt template like this. Okay, read the following list of points, and we just dump in the whole set of points and ask you to summarize this into a shorter list of themes. Okay. And so if you run that, that might take a while. But at the end, you should get back a set of themes that looks like this. Yeah, what we call cat. Right. So we, based on all of the posts that it has read, it has identified the following set of themes. Okay. So I think this looks quite nice. It may not be that great. There might be some repetition here and there, but at least it gives you a very quick overview, right, of the kinds of themes that I mentioned in your data set. Okay. Right, so if we run this prompt on that list of themes, we get a final set of themes, right? In this case, about 20 or so themes. And lastly, we might be happy with those themes. If your research project is just to uncover the themes, then then that's great, right? You have your list of themes, right? You can try and publish a paper, but I don't know if you can. Yeah, but maybe what you might want to do is to take the list of themes and then re-annotate the data set again. Okay, so we will do this with the following prompt. Again, we iterate through the whole data set, read the post, feed in the data, but this time the instructions are slightly different, right? We are asking which of the following themes are present in the post. Okay, and in that case, in that situation, we dump in the whole set of 20 themes. Okay. And here I'm asking it to list at most 5 themes. Okay, but you can change the number. Maybe you just want 1 theme or something like that. So if you do that, you end up with So this is what the next section of code is. It's going to look very similar to before. The only difference is that now we are using a different set of themes, a different prompt, right? Asking it to find out the themes. So if we run that again, it's going to take a while. Okay, and what you're going to get is the same data frame, but now in addition to the annotations, you're also going to get for every post a set of themes. Okay, so so it has finished, and if we now look at our data frame, we'll see in addition to the annotations, right, we now have a list of themes. Okay, so you can see that now these are always the same set of themes rather than all the different kinds of annotations there. Okay. Now, maybe for your analysis, you might find that you would prefer a table like the following. Okay, so I've included some scripts to convert the data into a table where the rows are the different posts, right? And then the columns are all the themes, and then you put a 1 if that theme is present in that post. Okay. So in order to do this, we will need our function contains. Okay, basically, what we're going to do is we're going to run through our posts, the themes for each post, and then we're going to check if each theme is present in that list of themes. So that's in section 6 here, right? We initialize a data frame of themes, and then step through each of our posts and extract the themes that we have saved, and then just check if each theme is present in that post. So if we run that, we get a theme in depth. If you look at what it looks like, it looks something like this. Here we have all our posts here, and then on the columns we have all the different themes, and a 1 or a 0 in each column, right? Saying whether or not that theme is present in the post. So, and if you want, you can concatenate it with your original data frame, and save it into a new CSV file. And so if you do that, you end up with it's in a different location. You end up with something like this. The final CSV file with your posts on this side and all the themes here, and whether each theme is present in that post. So if you think again at what we started with, right? What we started with was just this part of the data frame, right? We only had the posts, and then now just with a few lines of code and in a few seconds, right? If you just run the code, it takes only a few seconds. You end up with annotations for each post, and themes for each post, right? And also a nice table of whether each theme is present in that post, right? That you can then use to, for example, check correlations or things like that. Okay. So I think this is quite useful. This is kind of workflow is something that we do quite often, maybe with slightly different variations. Okay, but I hope that has been useful for you to learn, and hopefully you can use this to annotate your own data sets or transcripts or so forth. Okay. Any questions? Yes.
Thanks for your very useful tutorial. I want to ask 2 questions from my personal experience using language model. The first question is that when we give some instructions to the ChatGPT to generate some results, sometimes they may generate unnecessary information, but newly information that beyond my imagination. How do we deal with these situations? And the second question is about when I use ChatGPT to code my content, I found that sometimes they forget my instructions, and they give some new answers because I gave some primary instructions or code schemes, but they generally forget it. I give some new ideas or results. How do you think about it? Thank you.
Okay, yeah, so I guess in interest of time, I won't go through the other examples in the talk, but maybe I'll leave the slides up for you to see. But maybe just to go to the end of the talk, right? So the issues that you raised are also issues that we find in our tasks. Okay, and I guess maybe just to share some final list of principles when crafting these prompts, right? A good mental picture that you can have for the LLM is that they tend to be, you can think of them as very enthusiastic but inexperienced interns, right? So it's always going to try to please you by giving you a response, but like you said, it may not pay attention to the code book that you gave and so forth. Okay, so I think one thing that you can do in that case is to maybe I don't know how you're inserting the codes, but are you listing them all at once or one by one?
Sometimes I insert as a table, a whole
Yeah.
table.
Okay, yeah, so some things that you might want to do would be to break that down into a simpler task, right? So you can imagine an intern sees that big table, they'll get lazy and some nonsense replies, right? So instead of giving you all the codes at once, you could just give one code at a time. It means that you have to run through more times, right, for each code. Okay, but each time is only one code. And then it also helps to give examples of what counts as that code and what does not count as that code, right? So for each of those, so it's going to take more runs through the data set, but by making each prompt shorter and more specific, that might help. Yeah.
Okay. Thank you.
So this semester I was attending a qualitative research class, and the professors always express the golden standard of human to code this. And I want to ask a very practical that when submitted our articles to a journal, and we use ChatGPT or large language model to code annotate the system with us, and we clearly report this in the article. Is it widely accepted by this journal or some conference? So the current situation.
Yeah, so I think it depends on the journal, and I think a lot of journals are still hesitant on a purely LLM annotated result, right? So I think some things that you can do would be, of course, it doesn't make sense to get humans to annotate the entire data set again, right? Because then what's the benefit of using the LLM? But if you can get humans to annotate a small sample, or and then the LLM will annotate the full sample, right? And then just do a comparison there. It need not be a perfect correspondence, right? But if you can show that there's some degree of agreement, maybe 60%, 70%, right? That might be useful as well. Yeah. So I think we definitely shouldn't just have papers where the only person that has seen the data is the LLM, right? You do want the human to come in as well, but the humans can probably be spent on more useful things, or just a subset of the data. Maybe you want to extract out certain quotes or things like that, right? With this LLM annotated data set, you can then, as a human researcher, go in and select just those themes, right? And then look through a smaller set of codes and then extract them yourself. Yeah. But yeah, we don't have that much experience submitting to journals yet, because it's only been a year since LLMs have come out. So some of our papers are still in review. And then sometimes collaborators that we work with are a bit hesitant on using LLM as well. But I think it's a valid concern. I don't have any answers for that, but hopefully things will change. Yeah.
I'm sorry, would it be helpful if we compare the ChatGPT generated results with other LLM models or other text analysis?
Yeah, okay. So yeah, another way would be to use other LLMs or other text analysis tools. I don't know how much correspondence you're going to get if you do that. And I also don't know what it would mean if, let's say, ChatGPT agrees with Llama, right? And in the end, I think you still want a human to kind of ground the results in some kind of proof, right? Yes. But yeah, that's something you can do as well. So in CS papers, a lot of the times what they do is they have the same prompt, and then they just throw 5 or 10 different LLMs with the same prompt and then show the results, right? Yeah, but I think in psychology, you probably don't want to. It's not so meaningful to just have different LLMs.
Thank you.
I think it also maybe depends on like the complexity of the annotation task, right? Like, I mean, if there are some measures that are now commonly accepted, like for sentiment, if you use a software package to code for sentiment, I don't think they will come back and ask you, like, are you really careful with sentiment? It's kind of accepted that sentiment is an easier thing to attribute. But if you're trying to annotate for something complex, then definitely it's better to have a small sample where you have a human annotation as well in the ground truth. I think the complexity of the annotation task is also a factor.
And I think comparing, so back at HPC, we have this team where we actually had a full human annotation of the data set. So that was one paper, and then we are using LLMs to annotate the same data set and compare the two results, right? So in that case, you actually have a comparison between the LLM and the full human task, right? So just some observations that we had from there were that, like one of the participants said, the humans are probably better able to pick up nuances in the code book, like by coding, but humans get tired very fast. And so what we see is that maybe if they see the same thing happening a few times, they will code it correctly. But then if it keeps appearing, they stop coding that thing, right? These human annotators stop coding that theme, right? Because they've already seen it so many times before. Whereas on the LLM side, you don't have that problem, right? So I don't think it's always the case that human annotators would be a perfect ground truth. But I think they both have different strengths. Humans are better able to pick up nuance, but LLMs won't get tired and will be a bit more consistent, I think. They might be consistently wrong in some cases, but at least they are consistent, right? A lot more consistent than what humans do it.
Any other questions? So if we don't have any.
I'm sorry, I'm just asked the pricing of the GPTs.
Okay. Yeah, so I'm sorry, I took a bit longer on the tutorial part. So actually, if you look at the slides, right, I actually had more materials prepared for you. So maybe I will just briefly mention what they are. I won't go through them in detail so that you can look at them yourself. So first would be the pricing, right? So here is a table of the cost for the different models. So these are the slides that I've given you. You can see that, so today's model was the first one, and the cost is $150 per million tokens of input and $2 per million of tokens, right? What is a token? You can think of a token as a bit less than one word. Okay, so in the slide before that, I explained what tokens are. You can go and read it. If you want to estimate how many tokens your text is, you can use these estimates here, or you can use a Python package that gives you the exact count. Okay? But to put them in context, 1 million tokens is roughly the length of the English Bible. Okay, so it would take $2 to produce the same volume of text as the entire English Bible, right? So it's actually quite cheap. Okay, so but it may vary by different models, right? So here you can see the model that we have used is quite cheap. There's the open GPT 4.0 model. That's quite a lot more expensive. Okay. Then there are other models like Llama and so forth, Claude, right, that have different prices. Right. So this is the kind of price we have. I think when running the code today, none of you got a message saying that we ran out of money, right? So I think I only put in $10, and we run all this, and there's still enough money left. Okay, so it can. I think if you use cheaper models, it should be reasonable. Yeah, but it's a good idea to have an estimate of how much it's going to cost before you run like maybe 200,000 posts or something like that.
Of course, in some cases, you are not going to be successful just using one problem. Sometimes you need to change the prompts again and again, then it will cost more.
Okay. So good point. If you're testing different prompts, I would recommend you don't test them on the full data set, right? You test it on, just on 5 posts first, right? Once you're happy, then you run it on the whole data set. Yeah. The testing should be quite cheap because 5 posts or something isn't going to be.
Also, I think because like you have separate pricing for input and output. So if you're outputting like an entire paragraph versus just a label, that also has implications for how much you can invest.
Yeah. So you can ask the model only reply with agree or disagree, right? And then it won't give you any other kind of garbage, right? That you're paying for. Right? So yeah, that is. Yeah. So in the slides there are some other options that you can use. Today we only use OpenAI, but there are other models. But I think to use the rest, you probably need some knowledge of Python, right? It's a bit harder to use them in R. And then I actually had some other examples where we walk through, use GPT to analyze transcripts and to build a chatbot. Okay, so maybe I will just mention one interesting problem that we faced when using a GPT to analyze transcripts. So the transcripts look like these. They were anonymized transcripts. Okay, and we were interested in knowing what each participant's concerns were about different kinds of alternative proteins, right? And so you might think this is a task that GPT would be great at, and that's true, it did quite well, but one interesting thing that we found was that it got confused by the anonymized IDs, right? If we see a transcript like this, if I only want to know what participant 9 says, right? I don't want to know what participants 7 and 8 said, right? This is a focus group with multiple people, right? So multiple people are speaking at once. But it actually wasn't able to distinguish between the participants when we gave it a transcript like that. Okay, but when we replaced all the participant numbers with fake names, Alice, Bob, Peter, right? Then it did fine. Okay, so this is, I mean, this is not something that you expect, but this was one of the problems that we faced, and then it turned out to work like that. Okay, so just keep in mind it's trained on language and tokens that it normally sees, right? So you should try to do what you can to help it along, right? So it probably won't work if you put in like Singlish names as well, right? But putting in common English names in this case help. Okay, so just an interesting anecdote on sometimes the results you get may not be what you expect. Okay, so it's always good to test different prompts and try and see how you can help the LLM along. Okay, the LLM is just a black box, right? But you can change the way you prompt to help it along. Okay, so you can see examples there, right? And Brandon here actually, so this is about the online interviewer that Joe talked about, okay, that we saw previously. We did have some problems getting the LLM to know when to move on to the next question, right? And sometimes it's also too chatty with the participants. Okay, so each of these requires us to break it down into smaller steps, right? Instead of having a single prompt, right, we break it down to smaller steps. Maybe one LLM is just in charge of deciding when to move on. Another LLM would be in charge of deciding whether the previous LLM's response is too wordy and then shortening it. Okay, so I think here in the general, so this last point on the general principles, there are a lot of tasks that we as humans think of as a single task, right? That are actually not single tasks if you really think about it, right? As humans, we are used to doing these things like interviewing people, knowing when to move on. But the more you can help the LLM, the more the LLM can help you, right? So help the LLM by breaking it down to very small, specific tasks. Think through what's actually needed to perform the task and then feed it that context. Okay? And then I think you will be able to get responses that are more useful for your task.